Good afternoon. I am Rajatim Rao, and today I will be presenting on fault tolerance mechanism in distributed systems. In today's distributed system, reliability and availability are crucial. Fault tolerance ensures systems continue to function even when issues arises, which is vital for real-world applications like cloud services, financial systems, and more. In introduction slide, we will discuss what is fault tolerance. Fault tolerance refers to a system's ability to operate correctly even when components fail. It is an essential feature in distributed systems where nodes are spread across different locations. So, what is the importance of fault tolerance? Without fault tolerance, a single failure could disrupt services for millions of users. It ensures reliability, availability, and customer trust. So, what are types of faults in distributed systems? So there are multiple types of faults in distributed system. Uh, Number one is crash faults. In crash faults, imagine we have a server that crashes due to a hardware failure. The system must detect this and redirect tasks to other servers. The second one is omission faults. Omission faults mean failure in sending or receiving messages, like losing a packet in a network can disrupt coordination. The third one is timing fault. Timing faults mean delays due to a network congestion or slow processing can cause error in time-sensitive system. The fourth one is Byzantine faults. These are the most challenging. Nodes behave unpredictably, possibly due to malicious activity requiring robust mechanisms to handle. So, in this slide, we will discuss key fault tolerance strategies. So, the number one is redundancy. Redundancy involves duplicating resources like server or disk. For example, in a RAID setup, data is stored across multiple drivers, so a failure in one doesn't lead to data loss. The second one is replication. Replication create multiple copies of data processes. There are two types of replication: active replication and passive replication. In active replication, all replicas handle requests simultaneously, ensuring no single point of failure. And in passive replication, a primary node processes request and backup take over if it fails. So in this slide, we will discuss what is consensus algorithm. So in distributed system, nodes must agree on a single state or a decision even with faults. This is critical for maintaining consistency. So we have other popular algorithm as well, such as Paxos, which means known for its robustness. It ensures decisions are made despite crash faults. The second one is Raft. Raft is simpler than Paxos. It's widely used in systems like etcd and Kubernetes. And the third one is Byzantine fault tolerance. It is used in blockchain to handle malicious nodes. It ensures trust even in untrusted environments. Slide 6. So in this slide, we will discuss fault detection techniques. So we have heartbeat mechanism in which nodes periodically sends a heartbeat signal to indicate they are operational. If no heartbeat is received, the system flags the node as failed. The second one is timeouts. A node is considered unresponsive; it doesn't reply within a defined time. And the third one is failure detectors. These are logical components designed to identify and isolate faulty nodes, ensuring minimal disruption. So in this slide, we will discuss recovery techniques. So recovery techniques, we have first point of checkpointing. In checkpointing, system takes snapshots of their state at regular interval. If a failure occurs, they can resume from the last saved state. For example, we can take example of databases. Databases often use checkpointing to maintain transactional integrity. The second one is rollback recovery. When fault occurs, the system rollbacks to a consistent state, undoing incomplete operations. And the third one is reconfiguration. Tasks are reassigned to healthy nodes to maintain service continuity. So in this slide, we will discuss some real-world examples. The first real-world example we will see is the Google file system, which uses data replication to ensure high availability and durability. Amazon Web Services is also a real-world example. AWS employs redundancy and automatic recovery mechanism to guarantee uptime for its services. And the third one is blockchain. Blockchain networks such as Bitcoin achieve fault tolerance through distributed consensus, even when potential malicious actors. In this slide, we will discuss challenges in fault tolerance. So we also have some trade-offs. In trade-offs, we have cap theorem, it which says that it is hard to achieve consistency, availability, and partition tolerance simultaneously. For instance, highly available system may compromise consistency during failures. The second one is resource overhead. Uh, resource overhead, in which redundancy and replication increases cost and complexity. The third one is Byzantine faults. Handling malicious behavior requires complex algorithms like BFT, which are resource intensive. So, in the last slide, let's discuss conclusion. So, fault tolerance is essential for distributed systems to handle real-world challenges. Strategies like redundancy, replication, consensus, and recovery ensure reliability. So,